All right, part 2, identifying characteristics of other exponential functions. The following equations are in y equal ax to the b format, where y and x are the dependent and independent variables. A is a constant coefficient and b is the constant exponent. So a and b don't change. We just have to figure out what they are because they're constants. X is a variable, and when x changes, y changes along with it. That's what it means for x to be independent and y to be dependent, because whatever x is, that's what causes y to change. Okay, so here we go. When x equals 0, right here, the equation becomes a times 0, because x is 0. So this is y equals a times 0 to the b. Since 0 raised to any power is still 0, then the equation will always equal 0, no matter what the value of a is. This means when x equals 0, no matter what b and a is, y will equal 0. In other words, in the y equals ax to the b format, the y-intercept, in other words, the y value when x equals 0, is also always 0. Okay, so we get that right away. When x equals 1, the equation becomes a times 1 to the b. And since we know that y is 2, and we know that 1 raised to any power is still 1, then we know that the equation will equal y equals a times 1, because the 1 isn't going to change with that b. Therefore, if y is 2, then y has to be equal to a, so a has to be equal to 2. So whatever the whenever you have the 1 here, it's not going to change the x value, so therefore the y value will be equal to the a value. So when x equals 1, the y value is always equal to the a value. Therefore, since y equals 2, a equals 2. So simple thing, when x equals 1, you cannot, no exponent can change the 1 from being a 1. So you can look here too. A has to be the thing that makes this equal to 2, because all this business over here would be 1. So if a times 1 equals 2, then a has to be 2. So in this format, which is, just to revisit, y equals ax to the b, whatever x is, whenever x is 1, a will be equal to what the y is. So when x equals 2, the equation becomes 16 equals 2 times 2 to the b, since we already proved that a is 2. So then we can divide this by 2 on both sides, and we get 8 equals 2 to the b. And we know that 2 must be raised to the third power to get 8, because 2 times 2 times 2 equals 8, so b must be 3. Therefore, the equation reads y equals 2x to the third. All right, so what we did, we found the a by looking at the x equals 1, and then we found the b by solving at x equals 2. Okay, so then we're going to plot this into Desmos to be sure. So we got negative 1, 0, 1, 2, 3, 4, 5, 6. So negative 1, 0, 1, 2, 3, 4, 5, 6. And here we got negative 2, 0, 2, 16, 54. Negative 2, 0, 2, 16, 54. Negative 2, 0, 2, 16, 54. 128, 250, 432. 128, 250, 432. And what we're saying is that it's going to be y equals 2x to the third. So let's take a look here. And of course, we need to make sure that that exponent is listed as an exponent. And it would be helpful to be looking at some more reasonable numbers, but there we go. It's lining up, isn't it? Those dots are lining right on there. Even right there, we can zoom in extremely. Ooh, extreme close-up. It lines up perfectly. Okay, So the solution worked. All right, so let's try number 4. Find the y-intercept. The y-intercept in y equals ax to the b, the y-intercept will always be 0, so that's an easy one. Find the value of a, the constant coefficient. Again, y equals ax to the b. So when x is 1, no matter what b is, x to the b will also be 1. So then it's y equals a times 1. So if the y is 3, the a has to be 3. And that again is y is the reason why when x equals 1, this is your a value every time. Okay. Now find the value of b, the constant exponent. Here we are. When x equals 2, we have the equation. We're going to have to do a little work here. So I'll do it down here. Y equals ax to the b. We already figured out that a is 3. So when x equals 2, plug that in, we know that y is 48. So to solve this, first thing I'll do is divide by 3 to solve it. So then I know that 16, because 48 divided by 3 is 16, is equal to, the 3 is gone now, so that's just 2 to the b. So what number does b have to be to make 16? 2 to the b. So that's 2 times 2 is 4, times 2 is 8, times 2 is 16. So b has to be 4. So b has to be 4. How do I know that? Because it takes 2 times 2 times 2 times 2 to make 16. So basically I plugged in right here. I already knew the a was 3, so I put the a there. I knew that the y was 48, so I put that there. And I knew that the x was 2, so I put that there. I divided by 3, I got this equation, and I solved for b. So now we need to write the equation in y equals ax to the b format. So we say y is equal to a, which was 3, so we say 3x to the b, so we go to the, and then we figure out that our b was 4. So that's our equation. Now we're going to plot this into Desmos to see if we're correct. Negative 3, negative 2, la la la, all the way up to 4. So that's negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And here we go. 243, 48, 3. Really weird set of numbers. 243, 48, 3, 0, 3, 48, 243. Ah, it's a palindrome. That's nice. Look at that. 0, 3, 48, 243, and then the last one, 768. You'll actually notice, you might have thought it was weird for a palindrome here, but you actually get a lot of palindromes when you have even exponents. Something to keep in mind. Okay, so now we got to put y equals 3x to the 4th. Just try to match this. So we say 3x to the 4th. Look at that. I mean, look at it. It's perfect. It's excellent. What does that tell you? It tells you that our answer is correct. Good job. There's number 4.